Welcome to Unit 02, Lesson 03, Setup, Worked Practice Video Overview. So, have you ever written a piece of code that worked absolutely perfectly on your friend's computer, but then completely crashed on yours? It's incredibly frustrating, right? Today, we're going on a bit of a scientific detective journey into your Python setup to prove exactly where and how your code is running.
Here's our quick roadmap for today's explainer. We're going to start with the setup misconception, then examine the evidence, dive into the setup scenario, break it all down with claim evidence reasoning, and wrap things up with the transfer check.
All right, let's jump straight into Section 1, the setup misconception. Okay, we really need to bust a massive myth right off the bat. Installing Python, opening up an interactive interpreter, and actually running a script, these are fundamentally different actions. They are definitely not the same step. Think of the interactive interpreter like an active, ongoing conversation. It reads and executes your commands one by one, giving you instant feedback. Running a script, on the other hand, is like handing over a completed document. It executes the whole source code file from top to bottom all at once. If you mix these up, it's kind of like trying to feed a 50-page essay into a chat window. The context completely changes how Python handles your variables and your logic.
And this leads us into a pretty dangerous trap. The big misconception here is assuming that a program just runs identically in every single environment. A lot of folks assume that, hey, if I typed a command and didn't see an error pop up, my file must have run perfectly, right? Well, wrong. A completely silent terminal doesn't actually mean your code ran in the right place or used the right dependencies. It's a total false positive. You could have easily just accidentally installed a vital data package into your global system instead of your specific project folder. And honestly, that's just setting a ticking time bomb for your next coding session.
Moving right along to Section 2, examining the evidence.
So, looking at the Python 3.14 documentation, it hands us this incredibly important concept, the virtual environment. Basically, this is a self-contained directory tree that holds its own Python installation plus any extra packages you might need. Think of it like a completely isolated sandbox. Say you have different projects that need totally different versions of tools. This sandbox makes sure your variables and dependencies live safely inside their own space without bleeding out and messing up the rest of your computer. Like if Project A needs an older math library and Project B needs the absolute newest one, virtual environments keep them completely separate so they don't break each other.
Okay, so how do we actually build this sandbox? Well, the official docs give us a very precise command, python-mven tutorial inv. Let's break down what's happening there. We call Python, we use that little -m flag to run a built-in module, specifically the venv module, and we tell it to generate a brand new directory named tutorial env. And boom! Inside that folder is a fresh, completely isolated copy of the Python interpreter just sitting there ready for our exclusive use.
But wait, here's the critical limitation we really need to keep in mind. The documentation tells us the exact syntax to get this set up, sure, but simply running that command doesn't automatically prove your code actually ran inside the sandbox. It creates the environment, yes, but it does absolutely nothing to establish that your system pads are actively using it. We need hard, active evidence before we start throwing down data types or loops. We really just can't assume.
Which brings us to Section 3, the setup scenario.
All right, to actually step inside our sandbox, we have to activate it using specific scripts, and this depends on your operating system. For Windows users, it's tutorial-env/scripts/activate. If you're on Unix or Mac OS, you'll source it with source tutorial-env/bin/activate. But here's the golden question. How do you actually know you're inside? You gotta look for a crucial visual clue. Your shell prompt is literally going to change. When you see tutorial-env pop up at the very start of your command line, that right there is your primary evidence. It means your environment has been successfully modified to use this newly isolated installation.
Now that we've got solid visual evidence that our environment is active, let's run a quick example straight from the docs to test the whole thing out. We're going to start by assigning a Boolean data type to a variable. We'll say the world is flat equals true. Next up, we use a basic control flow tool, just a simple if statement, to check that condition. So if the world is flat. Now, if that evaluates to true, we execute a basic print statement. Be careful not to fall off. What we're doing here is proving that our logic works exactly as we'd expect, all safely contained within our newly constructed isolated environment.
Let's unpack this in Section 4, Claim, Evidence, Reasoning.
Okay, we need to piece together exactly what just happened, using a strict logical framework. Our claim here is that the script executed successfully inside our isolated virtual environment. So what's our evidence? Well, it relies on two distinct things. First,
the shell prompt visually changed to show our environment name, right? And second, the text, "Be careful not to fall off," was outputted directly to the screen. Finally, we have our reasoning, which ties the whole shebang together. Activating the VNV successfully isolated our system paths. Therefore, that prompt change proves our exact location, and getting the correct print output proves our variable logic ran exactly as intended, right there in that designated space.
And that leads us to our final section, Section 5, the transfer check.
So, what do you think happens if we drop out of our script execution and try to replicate this directly in the interactive interpreter instead? How does the actual evidence we need change when our workflow changes? It's honestly a fantastic way to test whether we've truly grasped the nuts and bolts of our Python setup.
Well, first things first, we actually have to leave our sandbox. To do this, the documentation tells us to simply type deactivate right into the terminal. And just like that, you are pulled completely out of the virtual environment, and your normal global system paths are restored. It's essentially like stepping back out into the main directory of your computer.
So now, back out in our global environment, we type Python 3.14 to invoke the interactive interpreter. But notice how our evidence requirements totally shift here. We aren't looking for that tutorial env label anymore. Instead, the docs explicitly state we need to look for the primary prompt. That's the 3 greater than signs, which tells us the interpreter is ready and waiting. And because our earlier if statement was a multi-line construct, we also have to keep an eye out for the secondary prompt, those 3 little dots. If we wanted to definitively verify our paths now, we check sys.path, which is literally the list of directories Python searches to find modules. See what we did? We transferred our skills, but we completely adapted our evidence to fit the brand new environment.
By tracking the right evidence, whether that's a changed shell prompt, a greater than sign, or a successful variable output, you can absolutely always prove exactly where your code is running. So the next time you hit run, ask yourself, are you really sure you know where your code is executing, or are you just blindly trusting a silent terminal? Unit 02, Lesson 03, Setup, Worked Practice Video Overview.